Good morning everyone. Welcome to my class. In this class I am going to discuss few important MCQ question based on the topic magnetic effect of electric current. Yes, everyone we know tomorrow you are writing Karnataka TET exam. For everyone all the best. Write the exam neatly, okay? Today is only the revision classes. How much possible I can discuss MCQ questions. What are the topic I left, that topic I will do the revision, okay? This topic is very important one, magnetic effect of electric current. First question, the most suitable material for making the core of an electromagnet is. To make a core of a electromagnet, which material we will use? They are asking the question. First option steel, second option iron, third option soft iron, fourth option is aluminum. Tell me the correct answer here. Correct answer for this question is option C, soft iron. The most suitable material for making the core of an electromagnet is soft iron. Let us move to the next question. Which of the following is not attracted by a magnet? In which one the material is not attracted towards the magnet? First option is steel, second option is cobalt, third option is brass, fourth option is nickel. Okay, very easy question. Tell me the correct answer. The correct answer for this question is option C, brass. Yes, everyone you know brass, it is not attracted towards the magnet because you know metals, magnetic materials, they will be attracted towards the magnet, especially metals easily they will attract. Okay, here brass, it will not get attracted by a magnet. Easy question, that's why at least maximum number of questions I can discuss with you. That's why I will go fast, because this one it is like a last minute revision. Watch the class, it will be helpful for you. Then next question, when a straight conductor is carrying current, first option there are circular magnetic field lines around it. Second option, there are magnetic field lines parallel to the conductor. Third option, there are no magnetic field lines. Fourth option, none of the above. Here they are asking the question, when a straight conductor is carrying current, in a straight conductor when it is carrying a current, which of the following is true? They are asking. What is the correct answer? Option A, it will be the correct answer. When a straight conductor is carrying current, then there are circular magnetic field around it. Yes, everyone you know this answer. Because already you know the concept, only here we are discussing the MCQ question. Next question, move to the next question. Fourth question, a plotting compass is placed near the south pole of a bar magnet. The pointer of the plotting compass will, in which direction the compass needle it will show? They are asking the question. Option A, point away from the south pole. Option B, point parallel to the south pole. Option C, point towards the south pole. Option D, point at right angles to the south pole. Here understand the question. A plotting compass is placed near the south pole of a bar magnet. The pointer of the plotting compass, it will be in which direction it will show? Option C, it will be the correct answer, pointing towards the south pole. Okay, let us move to the next question. Yes, these are the easy question and also very important question for the tomorrow TET exam. Okay, two magnetic fields lines are A, intersect at the neutral point, B, never intersect each other, C. Intersect near north pole or south pole. D. Intersect at the midpoint of the magnet. Yes, option B. Two magnetic field lines, they will never intersect each other. Magnetic field lines, they will not intersect at any point, they will be not intersecting. Next, question number 6. A student learns the magnetic field strength around a bar magnet is different at every point. Which diagram shows the correct magnetic field lines around a bar magnet? Here they are included the figure here. Which figure is correct, they are asking. Option A, option B, option C or option D. Which one is the correct one? First option, this is the second option, this one is the third, this one is the fourth. Seeing the diagram only you can tell option C, it will be the correct. Yes, because this is the bar magnet. Here the magnetic field lines, they will move from north pole to south pole in this direction, and at the pole they will emerge from north, move towards the south. Diagram, C diagram, it will be correct. Okay. Next question. Question number 7. The front face of a circular loop of a wire is in the north pole. The direction of current in the face of the loop, it will be clockwise. Option A, clockwise. Option B, anti-clockwise. Option C, towards north. Option D, towards south. Tell me the correct answer. The front face of a circular loop of a wire is in the north pole. The direction of the current in this phase of the loop, it will be in which direction? Option B, it will be in the anti-clockwise direction. Okay, it will be in anti-clockwise direction. Let us move to the next question now. Question number 8. Yes. Which of the following statement is correct regarding magnetic field lines? Among these four, which statement is incorrect, they are asking. Underline in the exam also, it will be helpful for you. Option A, the direction of the magnetic field at a point is taken to be the direction in which the north pole of a magnetic compass needle points. Option B, magnetic field lines are closed curves. Option C, if magnetic field lines are parallel and equidistant, they represent zero field strength. Option 4, relative strength of the magnetic field is shown by the degree of closeness of the field lines. Which one is wrong? Option C, it will be the wrong. See, if magnetic field lines are parallel and equidistant, they represent zero field strength. Nowhere you will get zero field strength. Around the magnet, everywhere you will experience a magnetic field. Nowhere you will feel a zero magnetic field strength. Therefore, option C is the wrong one. Okay. Wait a minute. 1 minute. I will close the window. Some disturbance is there here. Okay. Then next question. Yes. Next question. Okay. The magnetic field inside a long straight solenoid carrying magnetic field, what is the strength of the magnetic field, they are asking here. How it will be varying, they are asking here. Option A is 0. Option B decreases as we move towards its end. Option C is the same at all points. Option D, increase as we move towards its end. The magnetic field inside a long straight conductor. Here they are, if they ask the magnetic field at the poles, it will be maximum. But here, here they are asking the magnetic field inside a strong straight solenoid. Means option C is the correct one, is the same at all the points. If they asked at the poles, means you have, at that case you have to tell it will be maximum. That's why understanding the question then answering also it will be very important. Next question, question number 10. Next, a strong bar magnet is placed vertically above a horizontal wooden board. The magnetic field lines of force will be option A, only in the horizontal plane around the magnet. B, option B, only in the vertical plane around the magnet. Option C, in horizontal as well as vertical planes around the magnet. Option D, in all the planes around the magnet. What is the correct answer here? Option D, in all the planes around the magnet. A strong bar magnet is placed vertically above a horizontal wooden board. The magnetic field lines of force will be in all the planes around the magnet. Everywhere you will feel the magnetic field. Next question. A student places some iron fillings around a bar magnet. Okay. The iron fillings arrange themselves as shown in the figure. Yes, iron fillings. A student place some iron fillings around a bar magnet. Then iron fillings they will get arranged as shown in the figure. Then here they are asking the question. The students label 4 different regions. Here P, Q, R, S. This one is P, this one is Q, this one is R, this one is S. Okay, 4 different places, they are 4 different regions around the magnet. Where would the magnetic field strength? It will be strong. At the poles it will be strong. At the poles, here at the pole. Okay, therefore R is the correct one. Here they are given. Yes, option C is the correct one. At the poles, almost around the magnet, the magnetic field strength it will be same, almost same, but at the poles, at this region here and also in this region, at the poles it will be maximum. That one you have to remember. Next question, question number 12. The strength of the magnetic field inside a long current carrying straight solenoid is more at the ends than at the center, minimum in the middle, same at all points, found to increase from one end to another end. Option C. Almost same type of question, same at all the points. Repeated question I will not explain more. Okay, easy one only. Option 13, sorry, question number 13. Which option explains Fleming left hand rule to understand working of a motor? Which one? It will tell Fleming left hand rule. They are asking the question here. First option, when a current carrying conductor is moved with force, it creates a magnetic field. Option B, when a conductor is moved inside a magnetic field, the current is produced in the conductor. Option C, when the magnetic field is moved relative to the conductor, the current is produced in the conductor. Fourth option, when a current carrying conductor is placed in a magnetic field, it experiences a force from the magnetic field. Which is the correct answer here? Option D. Fleming left hand rule. When a current carrying conductor is placed in a magnetic field, it experiences a force. It experiences a force from the magnetic field. This is the definition of a Fleming left hand rule. Remember, okay? Easy questions. The force on a current carrying conductor when placed perpendicular in a uniform magnetic field is if option A, if it will be BIL. Option B, if it will be B divided by IL. Then option C, if it will be L divided by BI. If it will be I divided by BL. Which one is the correct one? Option 1, force. It will be equal to BIL. The force on a current carrying conductor when placed perpendicular in a uniform magnetic field, force it will be PIL. Next question. A student insert a bar magnet in the coil. The student observe deflection in the galvanometer connected to the coil. What will happen if the magnet is continuously getting in and out of the coil? What will happen? Okay. If a magnet is continuously getting in and out of the coil. The current, option A, the current induced in the coil, it will be increases. Option B, the current will change its direction continuously. Option C, the magnetic field will create a motion in the coil. Option D, the magnetic field of the bar magnet would keep decreasing. Option D is the correct answer. See, when you insert a bar magnet into the coil, then you will observe a deflection in the galvanometer. Then if the magnet is continuously getting in and out of the coil, what will happen? The magnetic field of the bar magnet would keep decreasing. Magnetic strength, it will be get decreasing because of the movement of the continuous movement of the magnet in and out of the coil. Remember, easy questions. Okay. This is the figure. A metal rod PQ, this is the metal rod PQ, is placed in a magnetic field. This one is the magnetic field. If it is placed in the magnetic field, the end of the rod are connected to a battery. This is the metal rod. Then this metal rod is connected with the help of a battery. Then a metal rod PQ is placed in the magnetic field. Okay. Then the end of the rod are connected to a battery using wire. Then they are asking the question, where will the rod move? In which direction the rod move? First option upward, second option downwards, C into the field, out of the field. Option D is the correct answer. Out of the field, the metal rod it will move. Sorry. A metal rod PQ is placed in the magnetic field. The end of the rod is connected to a battery with the help of the wire. In which direction the rod it will move? The rod it will move out of the field. Next question. Question number 17. A soft iron bar is introduced inside a current carrying solenoid. The magnetic field inside a solenoid A decreases, B will increases, C will become 0, D will remain unaffected. Option B will increases. A soft iron bar is introduced inside a current carrying solenoid. Already solenoid is there. If you increased a soft iron bar inside a current carrying solenoid, the magnetic field strength inside a solenoid, it will be increases because extra soft iron you are introducing into the solenoid. That's why magnetic field strength it will be increases. Yes. Assertion. As the speed of the coil in the motor increases, there is a reduction in the current flowing through it. Reason, during rotation in an electric motor, some induced current is produced. Then among these four combination, which one is correct they are asking. Option A is incorrect, R is correct. Then second option A is correct, R is incorrect. Then option C, both A and R are correct, but R is not the correct explanation of A. Then fourth option, both A and R are correct, but R is the correct explanation of A. What is the correct answer? D. Yes, both also correct. Both also correct, but R is not the correct explanation of A. As the speed of the coil in the motor increases, there is a reduction in the current flowing through it. But here they are given the reason during rotation in an electric motor some induced current it will be produced, but no, there is no production in the induced current. There is no induced current it will be produced. That is the wrong one. But statement A and R are correct. But explanation related to A is not correct one. Here why they are given, but that also I got confused. Both A and R are correct. R is the correct explanation of A, and here and has to come. That's why I got confused. Both the, yes, some current it will be produced. A and R both also correct, and also R is the correct explanation of A. But is there no? That's why I also confused. Which of the following correctly describe the magnetic field near a long straight wire? Option A, the field consists of straight lines perpendicular to the wire. Option B, the field consists of straight lines parallel to the wire. Option C, the field consists of radial lines originating from the wire. Option D, the field consisting of concentric circles centered on the wire. Option D is the correct answer. Here, which of the following correctly describe the magnetic field near a long straight wire? Always the magnetic field lines, the field lines consisting of a concentric circles like this. Center it will be same. They will be like this, concentric circles. Center for all the circles, center it will be same. Next question. I will move fast because less time is there. You have to prepare for, after this class, one more class I will do polymer, because for polymer I not discussed any MCQ questions. Please see that one. Okay, polymers, please, whenever you are having free time, please revise that one. MCQs I am going to discuss in the next class. Okay. Then question number 20, for a current in the long straight solenoid, north-south poles are created at the two ends. Among the following statement, incorrect statement they are asking. The field, option A, the field lines inside the solenoid are in the form of a straight lines, which indicate that magnetic field is the same at all the points inside the solenoid. Second option, the strong magnetic field produced inside the solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside the coil. Option C, the pattern of magnetic field associated with the solenoid is different from the pattern of the magnetic field around a bar magnet. Then last one, the north-south pole exchange position, when the direction of the current through the solenoid it will be reversed. Here option A, B, D, everything is correct. Option C, the pattern of magnetic field associated with the solenoid is different from the pattern of the magnetic field around a bar magnet. No. Solenoid is also one of the type of a bar magnet. Okay, solenoid also is one of the type of the bar magnet. Then how the pattern of magnetic field they will be different from solenoid and bar magnet? No, both also it will be same. Option C is the wrong one here. Option A, B, D all are correct. Here they are asking the incorrect statement. That's why I underlined. In the exam also, don't get confused. A student makes an arrangement to study electromagnetic induction as shown. Here they are given the diagram. Galvanometer is there. Then coil of wire. Okay. Then here north south pole of a magnet they are given. She changes the arrangement in 4 different ways. Okay, this the, okay, leave this one. Okay, this is the practical based question. Okay, leave that, it will not come for you. Practically based one, that it will not, they will not ask in TET. They will ask in gpstr or hstr advanced level. Okay, leave that question. Next question. Appliances that have a metal body are generally connected to the earthing wire. What is the reason to do? What is the reason to earth these wires? What is the reason for earthing wire in our home? Normally, in the every one home, all the wires, it will be at the final wire, it will be like earthing. Option A, to prevent the excess current. Option B, to prevent the leakage of current. Option C, to provide extra current to the appliances. To provide, option D, to provide high resistance to the appliances. Option B is the correct one, to prevent the leakage of current. Yes, option B. What is the correct answer for this question is option B, to prevent the leakage of the current. Earth also, it will behaves as a one of the source, correct? No, appliances that have a metal body are generally connected to the earthing wire. What is the reason to earth these wires? To prevent the leakage of the current. Okay, this is the last question I discussed. Okay, at least few important questions I discussed here in yes, few important question I discussed here, magnetic field of electric current. Then in the next class, I will discuss the topic polymer. Okay, sorry. Okay, I will discuss in the, I will I will take one more class in based on the topic polymer. We will meet in the next class. Okay, take care, bye bye, read well, all the best for tomorrow.